to the introduction to exponential functions and laws of exponents. So what are the laws of exponents and what is exponent basically? Okay, exponent is the power. So for example, I have x to the power 2, so 2 is called the exponent. So this is the exponent. There are some rules for the exponent product rule. X to the power n, x to the power m, n and m would be added. If the bases are same, if I have x to the power n, this is called base. This is called exponent or power. So if the bases are same, the exponents are going to be added. For example, in this x and x base is same, so 8 plus 3 would be 11. 2 and 2 base is same, so 4 plus 2 would be 6. So here x and y bases are same, so for x 3 plus 2 would be 5. For y 4 plus 1 would be 5. Quotient rule. If the two components are dividing xn over xm, then the exponents when bases are same, x and x base are same, the exponent would be subtracted, n minus n. In the product it would be added, but in the quotient it would be subtracted. So 5 minus 2 would be 3, 5 minus 3 would be 2, and 2 minus 1, so here it is x square and here it is x to the power 1, so 2 minus 1 1, y to the power 5, y to the power 3, so 5 minus 3 2. Okay, so if we have any base to the power 0, the answer would be 1. If we have 2 to the power 0, it's 1. If we have 2022 to the power 0, it would be 1. So if we have any exponent 0, y to the power 0 is 1, 6 to the power 0 is 1, this whole number to the power to the exponent 0 is 1. Power rule. X n and m is equal to x n dot m. If it is like this, the exponents are multiplying. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Expanded power rule. X to the y m can be written as xm ym and xy over m can be written as xm over ym. For example, I have 2a cube, I can write as 2 cube a cube, which is equal to 8a cube. Or if I have 6, I can write it 6 square x cube square, which is equal to 36 x to the power 6. Negative exponents. If I have a negative exponent, I will make it positive by converting it into the denominator if it is in the numerator. As it is in the numerator, I will make it down to the denominator, it will become positive. If it is in the denominator, I will take it to the numerator, it will become positive. So x to the negative of 3 is 1 over x cube. 4 negative to 1 over 4 square is equal to 1 over 16. So here it is minus 4 x to the power 5 y to the power minus 2. Minus 4 x to the power 5 is already positive. The negative is on y, so y will come in the denominator with 2. Whenever we have negative exponent, we will take it into either numerator or denominator. We will reverse the fractions and we will get the positive answer. So can you simplify these expressions? 2 cube x square cube, y 8 minus 9, y negative 1, 1 over y. 6 3 plus 2, 6 5. Minus 5 to the power 0 is 1 x. Bases are same. Two is in the denominator, so it would be subtracted. Have you ever heard the saying breed like rabbits? In the bunny problem, you will investigate 4 different scenarios of rabbit breeding and creating a rule for each scenario. Make a table. Start with 2 rabbits. Each pair has 2 babies per month. So starting with 2, it would be 2, 4, come up with the rule, it would be 2 into 2 to the power m. So here it was 2 into 2 to the power 0, 2 into 1, which is 2, start with 10 rabbits. Each pair has 2 babies per month. Start with 2 rabbits. Each has 4 babies per month. So what is an exponential function? Exponential functions are different than every other function we have studied so far because they have a variable x in the exponent position, a b to the power x, where a can never be equal to 0, b can never be equal to 1, and b should be equal to 0. b is the rate of the growth. The table shows example of exponential growth and exponential decay. Examine the entries and come up with a rule to determine if an equation represents growth or decay. So if b is greater than 1, greater than 1, greater than 1, greater than 1, greater than, so if b is greater than 1, so it represents growth. B is less than 1, so it represents decay. So if b is greater than 1, it means growth. B is less than 1, it means decay. Okay, let's simplify this. Graph the function f of x is equal to minus 1 by 2x minus 3 plus 5, clearly showing any asymptotes and at least 3 exact points. So let us take x is equal to 1. Today we are going to start the 4.4 lesson, solving exponential equations and modeling. So we are going to learn how to solve exponential equations and how to do the modeling using exponential equations. So on the first time, I have a warm up. Complete the table and write an exponential equation that best fits the data below. You can use your calculator. So the formula to find the exponential equation is f of x, which is equal to a b to the power x. So what is a? It is the first term, and the first term here is 10. And what is b? B is the exponential growth. So we will find the exponential growth like this, that between 10 and 15 it's 15 divided by 10, which is equal to 1.5. Between 22.5 and 15 it's 22.5 divided by 15, which is equal to 1.5. So b will be 1.5. So writing this in the form f of x is equal to a, which is 10, b, which is 1.5. Now we need to calculate for x is equal to 3. So we will put 3 over here and we will get our desired answer by using calculator. So it would be 33.75. Similarly, we will do for a b to the power x. A is 10, b is 1.5, and here x is 4. We will get 50.625. So we can write these values in the table: 33.75, 50.625. Okay, solving exponential equations. Use an approximation to solve each of the following equations for x. No calculators. So if 3 to the 1 is 3, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, so 3 to the power x is 11, because 3 to the power 2 is 9 and 3 to the power 3 is 27. So 3 to the power x is 11. So what would be x? It is between 9 and 27. So it's nearest to the 9, so it's 2.2. Can be 2.2. It's an approximation. So similarly, we will do for 2 to the power x is 15. So let's start with 2 to the power 3 is 8. 2 to the power 4 is 16. So 15 is between 8 and 16, but it is nearest to the 16, so it's nearest to the 4. So x would be 3.9. So with the help of this approximation, we're going to solve this. Okay. Algebraically solve each equation for x. So for solving algebraically, this is called the base and this is called the exponent. So where bases are equal, we will make exponents equal. So x minus 1 is equal to 5, x is equal to 5 plus 1, x is equal to 6. Okay, here bases are not same, so we will make the bases same. We can write 49 as 7 square. So now bases are same, we can make exponents same. 2x minus 3, which is equal to 2. 2x is equal to 2 plus 3. 2x is equal to 5. X is equal to 5 by 2. Okay. Algebraically solve the following. Okay, now the rule is we need to make the bases same. So it's 4 and it's 8. Bases are not same. तो जब बेसिस सेम नहीं होंगी तो हम क्या करेंगे कि बेसिस को सेम करेंगे. तो 8 को 4 बनाने के लिए व्हाट वी आर गोइंग टू डू इज़ 4 टू द पावर 2 इज़ 8. और ये जो x प्लस 1 है ये क्योंकि ऑलरेडी एक्सपोनेंट में है तो ये 7 आ जाएगा. नाउ क्योंकि बेस सेम है तो एक्सपोनेंट सेम हो जाएगा. ओके अब यहाँ पे भी हमारे पास बेस सेम नहीं है. So if the base is not same, we're first going to make base same and then we will make the exponent same. So it's 3. 3 can go over here on this side and divide by 48. So it can be written as 2x is equal to 48 divided by 3. can be written as 2x is equal to 16. So 2x is equal to 2 to the power 4. 2 to the power 4 is 16. So bases are same, we can make exponent same. X is equal to 4. Okay. Now this. Again, it's 1 over 125. So can we write it 5 to the power minus 3? Because 1 over 125 is 5 to the power 3. And when 5 to the power 3 is coming in, will come in the numerator, it will get the negative sign. So bases are same, we can make the exponent same. Okay. Now here again bases are not same. So let's first make the bases same and then we're going to solve this out. 27 can be written as the power of 3 to the power 3, 3x plus 1. 1 over 3 can be written as 3 to the power inverse, x plus 2. So we can write it like this: 3 to the power 3, 3x plus 1, which is equal to 3 minus x plus 2. So now bases are same. Here it is 3, here it is 3. When bases are same, we can make exponent same: 3x plus 1, which is equal to minus x plus 2. So 9x plus 3 is equal to minus x plus 2. 9x plus x, which is equal to 2 minus 3. 10x is equal to minus 1, and x would be equal to minus 1 by 10. Okay, modeling with exponential functions. If a quantity grows or decays by a fixed percent or regular intervals, the pattern can be modeled using these exponential functions. So exponential growth can be written as a of t is equal to p 1 plus r to the power t. What is p? P is the initial growth, r is the growth rate or growth decay, t is the number of times intervals that have the passed, a is the final amount. So if it is growth, we will use plus sign over here. If it is decay, we will use negative sign over here. So let's solve some questions using exponential growth and decay so that we could know that what is the practical applications of these. Okay, so the first question is, you purchase an antique state for $450. The value of the state increases 5.5% per year. So 5.5%, how much is it worth after 20 years? So it was 5.5%, which can be written as 5.5 by 100, which can be written as 0.055. Now it's asking after 20 years how much was increased. So formula is a of t is equal to p 1 plus r t. This is the formula. Okay, so now solving it. What is a of t? We need to after 20 years. So what it was, a principal amount was 450. 1 plus r is 0.055, and we need to find t is 20. So we need to find a of 20. Okay, let's solve it. So very simple, use your calculator. Do 1 plus 0.055 to the power 20. You will get 2.91775 something. Multiply it with 450 and you will get 1312.990871. Okay, when will the state be worth $2,000? Okay, now the worth of the state can be $2,000. So when can happen? So when means time. So a of t is equal to p 1 plus r to the power t. So it's 1 2 3 given. Principal amount is 450. 1 plus 0.055, and we need to find out t because it's when. So 450 will be divided over here. It's 2000 divided by 450. Okay, so let's divide 2000 divided by 450. You will get 4.44. Taking log on both sides, we will get log 4.44. It would be 0.647, which is equal to t. This t is going to come in the start. Log 1 plus 0.055, which is equal to 1.055. So 0.647 is equal to t log 1.055, which is equal to 0.02325. Now it will be divided over here. 0.647 divided by 0.02325, so it would be 27.860 years. Okay, a jet ski initially cost $4,200, but it depreciates at 9.4% per year. When will this jet ski be worth $2,500? So again, it's asking when. So whenever it's going to ask when, it means time. So a of t a jet ski costs 4,200, which is equal to p is 4,200, which is the initial amount. Cost 4,200, so cost is the initial amount. Nine point four divided by 100, which is equal to 0.094 to the power t, and it will be worth 2,500. So it's the, so again 2,500 divided by 4,200, one plus 0.094 to the power t. So 2,500 divided by 4,200, which is 0.595. 1 plus 0.094 is equal to 1.094. Okay, so log 0.595 is equal to minus 0.225. So it would be 5.7 years. Okay. You have inherited a diamond ring that had an appraised value of 2,500 in 1980. The appraised value has increased by approximately 6% per year. In what year will the ring be worth 35,000? So again the same thing is happening. We will put the formula. A of t is equal to p 1 plus r to the power t. So very easy. What was the actual worth of the ring? You have inherited a diamond ring that had an appraised value, means the appraised value is 2,500. So in what year the ring will be worth 35,000? So actual value of the ring would is 35,000. And the principal value or the initial value is 2,500. 1 plus 6% is 0.06, and t is something that we're going to find out. So 35,000 divided by 2,500, it is 14. 1 plus 0.06 is 1.06 to the power t. So we are going to take log on both sides. So it's log 14, 1.14. 45.2859. Okay, so they were saying that you have inherited a diamond ring that had appraised value of 2,500 in 1980. So the appraised value has increased by approximately 6% per year. In what year the ring will be worth 35,000? So worth of 35,000 we need to check. So it's in 1980 it was 2,500. So after 45 years, so 1980 plus 45 years, which will be equal to 2025. So in what year the ring will be worth 35,000? In 2025 ring will worth $35,000. The value of a new 4500 sailboat decreases 10% per year. So here it is the case where it's decreasing. What will be the sailboat worth? So it's A of t is equal to p 1 minus r t. The value of the new 4500 sailboat, so it's going to be 4500 1 minus 0.1. The value of a new 4500 sailboat decreases 10% per year. Because it's going to be in 1 year. Okay, so $2,500, when will be the sailboat of the word 2,500? So for 2,500 it's going to equal to 4,500 0.9 to the power t, because it's when, so we're going to find t. So 2500 divided by 4500, which is equal to 0.55, which is equal to 0.9 to the power t log So t will be equal to 5.579 years. Okay. The population of Utopia currently has 40,000 people and is growing at the rate of 3.5% per year. The population of Metropolis currently has 25,000 people, but it is decreasing at the rate of 1.6% per year. When will the two cities have the same population? So first of all, we will go for Utopia. Utopia has 40,000 population, which is 1 plus 0.035 to the power t. So we are going to solve this out, which is equal to 4123 1.035 to the power t. Metropolis, okay, it has 250,123 population, which is depreciates 1 minus 0.016 to the power t, which is 25,0123 0.984. Okay, so now we need to find t. When will the two cities will have the same population? So if you're going to find t, we will equate the two equations. Okay, so now 40,000 divided 250,000 divided by 40,000, 253 divided by 41 to 3, 6.25. Okay, so by solving this, we will get t is equal to 36.267 years. Okay, solve the following exponential equations, approximate where necessary. 2 to the power 3x is equal to 264. So we're going to write make the bases same. 3x is equal to 6, x is equal to 2. 2 to the power 3x is equal to, or we can write, oh, we need to approximate. If we need to approximate, 8 to the power 1 is 8, 8 to the power 2 is 16, 8 to the power 3 is 24, 8 to the power 2 is 64. What is happening here? But we need 20, so it's near a 1, so it's going to be 1.4, not equal to, approximately equal to. Okay, so here is 8x minus 3. We cannot write 32 in terms of 8, but we can write both of them in terms of 2. Okay, so it's going to be 5x minus 4 with 5 square x minus 6. So bases are same, we can make exponent same. It's going to be 6 inverse 11 minus x. Bases are same, so exponents are also going to be same. So is there any power of 8 which can give us 32? Because here it is 32, so there is no power of 8 giving us 32, so we will go and make both of the bases to the 2 to the power 3 x minus 1, 2 to the power 5, 3x minus 2. It seems to be a repeated question. Okay, so 1 over 16 can be written as 1 over 4 square, 4 to the power minus 2. Sorry, it's going to be minus 2 minus 2. And 16 and 64, it can be written in the power of 4. So we are done with it. Okay, so the next we have is Jill is studying a strange bacterium. When she first looks at the bacteria, there are 1,000 cells in her sample. The next day, there are 2,000 cells interviewed. She comes back the next day to find that there are 4,000 cells. Create a table and the rule of the function. The inputs and the decays have passed it after she began to study the sample. And the outputs are the numbers of the cells of the bacteria. So we are going to make a table. T is 0, so the cells were 1,000. When it was T was 1, the cells were 2,000. And when it was 2, the cells were 4,000. Okay, so it's a multiple of 2, multiple of 2. So now what we're going to find is what is base. Base is 2 and A is A of T, which is equal to 1,000 A B to the power T. Your collection of baseball cards goes to 150 in 1988. In 1994, the value of the collection had increased by approximately 7.5% each year. So how many years from 1988 to 1994? Time is 1994 minus 1988, which is equal to 6. So A of T, which is equal to 150, 1 plus 0.075 to the power 6, which can be equal to, after solving them all, it is equal to $231.50. Assume that a DVD loses 60% of its value every year in a video store. Suppose the initial value of the DVD was $80. What is the value of the DVD after 4 years? So A of T is going to be 81 minus 0.6 to the power T. So we need to find A of 4, which is equal to 80, 0.4 to the power 4, which is equal to $2.05. So we have completed this lesson and we have learned how exponential decays and growth occurs in the practical values. Thank you. Okay, so compound interest. Interest is money paid for the use of money. If you open savings account at the bank will pay you interest for as long as the account is open. If you borrow money from the bank will charge you interest for the privilege of using their money. So we are going to do some questions on the compound interest and half-life, and basically exponential functions are going to be used here. So suppose you have $100 to invest and know the several investment options, each offering 5% interest. The Bank of Montreal offers 5% interest compounded yearly. The compounded means that the bank looks at your new balance at the end of each period and calculates interest based on that. So the interest is 5%, and 5% means 5 by 100, which is equal to 0.05. So, and the amount in the 0 years was $100. So next time the amount would be 100 times the compound is, the bank Montreal offers 5% interest means that the bank interest compounded yearly. So because it is for 1 year, so we're going to multiply this with 0.05 with 1. We're going to add 1. So 1 plus 0.05, which is equal to 1.05. So now 100 times 1.05, which will be equal to $105.00. Now 105 multiply by 1.05, which will give us $110.25. Then it's going to be 110.25 multiplied by 1.05, which will give us 115.76. then 115.76 times 1.05, so it will give us dollar 121.55. Okay, the next question is the Bank of Saskatchewan offers 5% interest compounded quarterly or 4 times per year. This means that the 5% is divided into 4 parts over the year. So the bank pays 1.25% on the principal every quarter. So it's going to be 5%. So 5% can be written as okay, 1.25% can be written as 0.0125, and added per year would be 1, so it would be 1.0125. So it would be 100. Here it would be 100 times 1.0125, which will be equal to $101.25. So 101.25 times 1.0125, which is equal to $102.52. 102.52 times 1.0125, which is equal to $103.80. 103.80 times 1.0125, $105.10. Okay, the Bank of Nova Scotia offers 5% interest compounded monthly 12 times per year. How much saving will you have after 1 year and after 4 years? So again, the same formula that we used last time, that was A of t is equal to P1 plus R to the power t. So A of t here is after 1 year, A of 1 is equal to 100. 1 plus what is R? 0.05 compounded monthly 12 times, so it's divided by 12, and here it is 12. Solving this, we will get $105.12, and for 4 years, A of 4, which is equal to 100, 1 plus 0.05 divided by 12, and here we're going to multiply by 4. So here it is 12 times per year, but it is for 4 years, so 12 multiplied by 4. Okay, so $122.09. The Bank of British Columbia offer 5% interest compounded daily. How much saving will you have after 4 years? So after 4 years, it would be A of 4, which is equal to 100, 1 plus 0.05 divided by, okay, so it would be Bank of British Columbia offer 5% interest compounded daily. So we are going to take 1 year, and it would be 365 days in 1 year. So it would be 365, and for how many years? 4 years. So multiply by 4. So when we're going to solve this, we will get the answer $122.14. Okay, so compound interest is the interest earned on the original principal and all interest earned previously. In other words, at the end of each year, the interest earned is added to the original amount and the new sum of the money is reinvested. A of t is equal to P of 1 plus R over N nt. P is the initial investment, R is the annual interest rate, N is the number of compounded periods in a year, T is the time in years. So how much you deposit in an account that pays 6.25% interest compounded semi-annually to have a balance of $5,000 in 15 years. So this is the next question. So what is the information given? Okay, so how much would you deposit? Okay, first of all, let's write the formula. A of t, which is equal to P1 plus R to the power t. So how much would you deposit in an account that pays 6.25% interest, which is equal to 0.0625? So have a balance of 5,000. So balance is P. How much you deposit? Initial amount we don't know. 1 plus 0.0625 divided by Semi-annually यानी कि 2 times per years. So T is going to be 15 years multiplied by 2. So this is simple calculations. It's going to be 0.0625 divided by 2 plus 1 to the power 30. It's going to be 2.517. Okay, so 5000 divided by this is going to give us 1986. So P is equal to 1986.33 dollars. Okay, you have $2850 in an account that pays 4.12% interest compounded monthly. So now they're going to compound monthly. So if they're going to compound monthly, the value of the investment after 8 years. So A of 8, which is equal to 28501 plus 0.0412 divided by 12 months and 8 years, so 8 into 12. To solving this, we will get $3960. The time it takes to double the value of your initial investment. So double means 2 times is equal to 1 plus 0.0412 divided by 12 into T. So what is happening here? The time it takes to double the value of your initial investment. So the initial investment, we need to double it. So we need to find the time that would be taken. But 12 is that it is compounded monthly. So we have it in 12. But the other time we're going to find it like this. So solving this is 2 is equal to 1.00343 12t. Okay, let me take log on both sides, which is give us log 2 is equal to 12t log 1.00343. Log 2 divided by log 2 divided by log 1.00343, which will give us divided by 12, which is give us 16.853 years. So T is equal to 16.853 years. If compounding were quarterly, now it's going to go quarterly. What interest rate would you need in order to produce the same value after 10 years as compounded monthly? So A of 10 is equal to 28501 plus 0.0412 divided by 12 into 10. And we get the result $4299.99. Okay, the next is, now we need if compounded were quarterly, now we need 4299.99, which is equal to 28501 plus r over 4, because now we're going to go for compounded quarterly. So it's going to 4 into 10 years, because it was 10 years. So dividing this, we will get 1.50877, which is equal to 1 plus r over 4, and here it is 40. So it's going to be taking log on both sides, then 40 is going to come in the initial, going to be 0.178623 is equal to 40 log 1 plus r by 4. 40 will be divided over here. Now writing it in the power of e, it cancels log. So solving this, we will get r is equal to 4.134%. Okay, so radioactive decay and half-life. Half-life is the amount of time it takes for half of the radioactive atoms in a sample to decay or stabilize. Different atoms decay at different rates and thus have different half-life. Scientists use the half-life of carbon-14 to date according to the times. Okay, when an organic substance dies, the carbon-14 atoms begin to decay. If there were initially 100 grams of carbon-14 present in a sample, calculate how much carbon-14 remains after several half-lives. So after the first half-life, it will remain 50. After second half-life, 25. Third half-life, 12.5, and third 6.25. Sketch the graph to model to show how the amount of carbon-14 present in a sample changes with the number of the half-lives. Stop and think, will ever be a time when no carbon-14 atom remains in the sample? So what is happening here is number of half-lives are 1, 2, 3, 4, 5, and here it is 25, 50, 75, 100. So when it was 4, it was 6.25. So it was here, then it was increasing. Okay, so the next one is, if x is the number of half-lives, write an equation to model how the carbon-14 changes. So a of x would be equal to 100 1 by 2x, because we're dividing it with 2 every time. In 1947, earthenware jar containing what are now known as Dead Sea Scrolls were found in Israel. Analysis showed that the scroll wrappings contained 78% of carbon-14. How many half-life had passed by the time of the scroll were discovered? So 78 is equal to 100 1 by 2 to the power x, and x is going to equal to 0.358 half-lives. If the half-life of carbon-14 is 5730 years, how old were the scrolls? In what year were they created? So t is equal to 5730 multiplied by 0.358 is equal to 2051 years. So in 1947 minus 2051 is equal to minus 104. So it's going to be 104 BC. A quick Google search tells us that the Dead Sea Scrolls were written between 150 BC and 70 AD. What is it about these scrolls that enable scientists to use carbon dating to determine their age? The scroll wrappings were made from the linen, which come from the fibers of a plant. Okay, another way to represent the half-life of carbon-14 is using the equation A of T is equal to 100 1 by 2 T over 5730, where T is the number of years the substance has been decaying, 5730, and half-life of carbon-14. Otherwise, how this model works by filling this table below. Okay, so for 0 years it's 100. So because it's 1 by 2, so just divide it by 2, very simple. 50, 25, 12.5, 6.25. How does this model compare to the one in the part C? Input years, not half-life. In what circumstances would this model be useful if you want to solve for the half-life? If a sample carbon-14 had changed from 15 gram to 6.054 gram, how long had it been decaying? Okay. So exponential decay of a radioactive substance that can be modeled using the formula A of T is equal to P 1 by 2 T over H. P is the initial amount as usual. T is the time of the substance has been decaying for, and H is the half-life. So problem set, $1,000 invested in an account that pays 4.5% compounded or quarterly. What will be the balance after 10 years? So very easy. We're just going to follow the same formula. A of 10, which is equal to 1000 principal amount, 1 plus 0.045 divided by 4, and what will be the balance after 10 years? So it would be 4 multiplied by 10. Why 4? 1000 invested in an account, it has 4.5% compounded quarterly. So this is quarterly, so therefore it is 4. So R is 0.045 divided by 4, and here it is 4 times 10. So just solving this, we will get $1564. How much money must you initially deposit at a rate of 5% to have 15,000 is equal to P1 plus 0.05 divided by interest compounded quarterly again, so divided by 4 into 20, because 20 years. So by solving it, dividing it, we will get P is equal to $5552.50. Okay, Courtney want to have $5,000 in an account after 12 years that earns 7% interest compounded monthly. So now it's compounded monthly. So it's 5,000, which is equal to P1 plus 0.07 divided by 12, and compounded monthly for 12 years. So it's 12 into 12. So solving this, because this is very easy to solve, just simple multiplication and division. So I'm not solving it to 163.83. Okay, the radioisotope radon-222 has a half-life of 3.8 days. Okay, so it's A of how much of a 10 gram sample of radon-222 would be left after 15.2 days? 15.2, which is equal to 10, so it's going to be 1 by 2 T over 3.8. So let's solve this. What is T over here? 15.2 days, so it's going to be 15.2 divided by 3.8. Okay, so it would be 0.625 grams. Iodine 131 has a half-life of 8 days. A of if the amount of iodine 131 in the sample of 8 gram is 35 days. Because this is very easy, we need to put everything in the formula. What is 8? 8 is the days. 1 by 2 is in the formula. 35 by 8, because after 35 days in total was 8. So we are going to divide them and we will simply get the answer 0.386 grams. Sodium 24 has a half-life of 15 hours. So it's going to be, if a sample of sodium has changed from 18 gram to 1.1125 gram, how long is that been taken? So it's going to find the time t. So here it is a bit difficulty. A of t is equal to 18 1 by 2 t by 15 hours. So 1.125, which is equal to 18 1 by 2 t over 15. So dividing this, and in this question you need to take logarithm. So divide 1.2125 divided by 18. Let's do this. Okay, 1.125 divided by 18 is 0.0625. Log is equal to log 1 by 2 t over 15. So log 0.0625 minus 1.2041, which is equal to t over 1.5, and log 1 by 2 is minus 0.301. So now it's easy, just divide it and multiply it and we will get the answer of t, which is equal to 60 hours. After 42 days, a 2 gram sample of phosphorus 32 contains only 0.261 gram of the isotope. What is the half-life of phosphorus 32? So it's 0.261, which is equal to 2 1 by 2 42 by h. What is the half-life of? Okay, so divide it, take logarithm, and you will get h is equal to 14.296. So we are done with it. Thank you. Okay, find the amount that should be invested at 7% compounded semi-annually in order to have $2,500 in 10 years. So we are starting the review exercise of the exponential functions, and we are looking the first question at how we're going to solve it. So amount given is 2,500, which is equal to P 1 plus R is 0.07 by T is how many years? It is semi-annually, means 2 times in a year, and 2 into 10. So after solving it, I will get P is equal to 1256.41. Brock is saving money for a trip to the Bahamas that cost $2,500. She put $1,500 into a saving account that pays interest compounded quarterly. So it is 2,500 . So why I'm using this 4? Because the interest is compounded quarterly. So it's quarterly, so therefore I'm using 4 over here. And 4 into 4 because it's 4 years. 4 years into 4. So after solving this, I will get 5 by 3, which is equal to 1 plus R by 4 to the power 16, and now we will take log on both sides. So it's going to be log 5 by 3. Zero 0.221, which is equal to 16 log 1 plus r by 4. So we will divide 16 here, take exponent, and finally we will get the answer of r, which is equal to 0.129, and in percentage it will be equal to 13%. Okay. A floral shop has purchased a delivery van for 21,000. The depreciation on the van is 11% per year. How long will it take for the van to decrease the value of 12,000? So it's going to be 12,000, which is equal to 21,000. 1 minus 0.11 t. Simply by calculations, we can get the value of t, 4.802 years. Living organisms can be dated by the amount of carbon-14 present at time t compared to the amount present when the organism was alive. The half-life of carbon-14 is 5730. How long would it take for a 155 gram sample of carbon-14 to decay to 24 grams? So it's decaying to 24 grams, and total was 185, and it's the half-life t by 5730. And now just solve it, and we will get t is equal to 16882.981 years. A fossilized piece of wood is found to contain 45% of the normal level of carbon-14 present when a tree of this type is alive. So it's going to be estimate age of the fossil. The half-life of carbon-14 is 5730 years. Okay. (45) is equal to 100. 1 by 2 t over 5730. So t will be equal to 660097. I hope you can do the calculations now, as we're in the remaining portion. So half-life of the radioactive cobalt is 5.27 years. 100 gram of cobalt are present now. How much will be in 15 years? So 100 is equal to x 1 by 2 5 by 5.27. X is equal to 193.022 gram. How much was present 5 years ago? It's 15 years, so 15 by 5.27, which will be equal to 13.905 grams. So how much after 5 years ago? 100 is equal to x 1 by 2 5 by 5.27. So x is equal to 193.022 grams. Okay. So there are three options for investing $500. At first, A1T earns 7% compounded annually. The second, A2T earns 7% compounded quarterly. Third, A3T earns 7% compounded monthly. Write the function that model each investment. So it's A1T which will be equal to 501 plus 0.07 divided by 1 into t. If it would be A2T, it would be 501 plus 0.07 divided by 2, A2T. There are three options for investing 500. First, A1T earns 7% compounded annually. The second, A2T earns 7% compounded quarterly. Quarterly would be 4. So it would be 40. And third, A3 and 7% compounded monthly. Monthly would be 12. So 501 plus 0.07 divided by 12t. So A1 5. Now we're going to substitute 5 over here. So 500, 1 plus 0.075 is equal to 701.28. Okay, 500, 1 plus 0.07 divided by 4 into 5 into 4, which is equal to $707.39. 500, 1 plus 0.07 by 12, 60, which is equal to $708.81. Oil is leaking from a tank at the rate of 4% per hour. The tank had 250 gallons of oil when it was full. Write a formula for the amount of oil in the tank after T years. So it would be A of T, which is equal to 250, 1 minus 0.04 T, which is equal to 250, 0.96 T. How much oil remains in the tank after 10 years? What percent of the oil has leaked out at that point? A10, which is equal to 250, 0.96 into 10, which is equal to 166.208 gallons. So total it was 250 minus 166.208, which is equal to 83.792 gallons leaked out. So because they're asking what percentage of oil has been leaked out, to find the percentage we will do 83.792 divided by 250 multiplied by 100, which is equal to 33.517%. Okay, how long will it take for $100 to triple if it is invested at 8.75% compounded monthly? So it would be okay, so here we have to triple $100. $100 to triple means 100 into 3 is 300, which is equal to 100. 1 plus 0.0875 divided by compounded monthly, it's going to 12 T. Now doing all the logarithm process, we will get T is equal to 12.6 years. Okay. Graph each of the following showing at least 3 exact points in any asymptotes. Okay. So be sure to clearly show the shape of the function and pay special attention to the end behavior. So f of x is equal to 1 by 2 x minus 4. So we need to take any 3 points, and by taking the 3 points we need to show the graph over here. So I'm just zooming it out. We can write it as 2 inverse x minus 4. So we will take x and y values. So if x is equal to 3, it would be 3 minus 4 is minus 1 minus minus 1 plus, so it would be 2. If x is 4, y would be 1, and if x is 5, it would be 0.5. So when x, this is x. So when x is 3, it's 2. When x is 4, it's 1. When x is 5, it's 0.5, like this. So the graph is moving in this way. And this is the point of So graph is not approaching there, but it's actually moving nearest to the 0. So the point where it's actually trying to approach is called asymptote. I'm marking it with red. Okay, f of x is equal to 2, 3 to the power x plus 3. And now we need to take the values of x and y. If x6 minus 1, y would be 3.66. For 0 it would be 5. For 1 it would be 9. Okay, 1 by 2 x minus 4, again it can be written as 2 inverse x minus 4, which is equal to 2 minus x plus 4. So now finding the values of x and y, because this is the same equation as above, so we will just use the again same values, that is 3 for its. For 3 it's going to be 2, for 4 it's going to be 1, for 5 it's going to be 0.5, going to move like this, and this would be the asymptote. Okay. For 4 it's going to be minus 2. So the graph is moving in this way. Trying to approach 5, so this is the asymptote. Minus 4, it's going to be minus 0.5, minus 3, minus 1, minus 2, minus 2. Okay, so for minus 1 it's going to be minus 3, for 0 it's going to be 1, for minus 1 it's going to be minus 3, for 0 it's going to be 1, for 1 it's going to be 2.3. Okay, write the equation of the following graphs. So how we are going to write the equation of the graphs? Okay, so first of all I'm going to see this point is 2, 4, and here we have I'm writing the actual equation over here. Y is equal to AB x minus h plus k. Okay, so in question number 1, here this is minus 2, so k is equal to minus 2. Here it is 1, so h is equal to 1. The distance is 1, 2, 3, so a is equal to 3. So let's use the equation y is equal to a, which is 3, b, which is not given, x minus h, which is 2, x minus h, which is 1, minus 2. Okay, and taking this point 2 and 4, what we're going to do is y is equal to 3b x minus 1 minus 2. 4 is equal to 3b 2 minus 1 minus 2. So b is equal to 2. So okay, for this we have 2 points. The point is minus 4 and 3, and this is the point where we have okay. So this is the point k is equal to 1. This is the point h is equal to minus 3, and here the distance is a is equal to 1. So the equation would be y is equal to a is equal to 1, y is equal to a is equal to 1, b x minus h plus k. Putting minus 4 in 3 is equal to b minus 4 plus 3 plus 1, b is equal to 2. So y is equal to 1 by 2, x plus 3 plus 1. Okay, so for this graph we have a point, let's say over here the point is 4, 14. Let's say another point over here, one, 2, 3. A is equal to 3, h is equal to 2, k is equal to 2. So y is equal to 3b x minus 2 plus 2. 14 is equal to 3b 4 minus 2 plus 2. b is equal to 2. So the equation will be three dot 2 x minus 2 plus 2. Let's take 2 points over here. It's going to be 0, 6, and another point is Okay. So the table below lists a few values of h of x, an exponential function of the form h of x is equal to a b to the power x. Determine the values of a and b and hence write the equation for h of x. So h of x is equal to a dot b to the power x. H of x is 196 when a and b to the power x is cube. H of x is 4 when a to the b to the power is 1. Now if we divide this, so we will get 49b square, b is equal to 7. So it would be 4 is equal to a to the power 7 to the power 1. A is equal to 4 by 7. H of x is equal to 4 by 7. 7 into x. Solve the following, very simple. You just need to make the base same and then equate the exponents. So you can see this is the quadratic equation, so we will use quadratic formula. So it can be written as 2 inverse x minus 1, which is equal to 2 to the power 5, x plus 3. So it can be 2 minus x plus 1, which is equal to 2, 5x plus, so minus x plus 1. It's going to be 1 by 9 to the power 2x. 3 times 3 is 9 and 3 times 3 is 27. So x is going to be equal to 0. And I'm sorry for this, I'm doing this again. Okay, so because it would be 2 to the power minus 2 x minus 1, 2 to the power 5 x plus 3, so minus 2x plus 2, which is equal to 5x plus 15. 2 minus 15, which is equal to 5x plus 2x, which will be equal to minus 13 is equal to 7x. So x is equal to minus 13 by 7. Okay, 3 to the power minus 3x plus 3, which is equal to 3 to the power minus 5, minus 3x plus 3 is equal to minus 5, minus 3x is equal to minus 5, minus 3, which is minus 8, x is equal to 8 by 3. 6 inverse is equal to 6 square. 3x minus 1 is equal to 6x minus 1 by 6 is equal to x.
4 cube is equal to 2x minus 3 is equal to 4 square. Four cube 2x minus 3 is equal to 4 square. 3 to the 6 minus 3 is a 9. Okay, so 2.6 can be written as 6 minus 3 is equal to 6. 3 minus 3x minus 3 is equal to 3 minus 3x. Minus 3. Okay, so we are done with the review exercise for the exponential functions. Thank you.